Here's an introduction into the proof of concept system for the spring set and drill machine. It's going to work on the clasp, rotator, and rotator body assembly. Okay, first module is the linear motion module. This is a linear drive with integrated load cell and collet closer for grabbing onto and pulling the push tube or pull tube. Next we have the nest that the clasp, rotator body assembly sits in with the 3-jaw chuck. This is a unique chuck in that it is open in the middle so that the push tube can be assembled at the same time. The rotation is accomplished by rotating this 3-jaw chuck in this worm gear drive system with its stepper motor. And we have the drill module, which guides the drill into the rotator body. Then we have the pneumatics and electrics. These two modules here are the motor controllers for the linear and rotation components. We have the PLC, which is the supervisor for the whole process, and we have the load cell signal conditioner, which feeds an analog signal back to the PLC. Power supplies, data acquisition systems, another power supply, and then we have the computers that program the modules, the individual controllers. This one is for the rotation. This is the rotation program. This is part of the PLC program, and this one here is for the linear motion. They each have individual programs that talk to each other during the process. Now we're going to install the parts into the system. We have the rotator body assembly, fits into the nest right here. It's done. It's held in place on this machine with a disc stapler clamp. And then we have the push rod, slides in axially to the back, and then through collet closer. And in this case, we're using a manual collet closer. The final machine is going to have a pneumatic automated collet closer. Parts installed. The PLC asks us to press select to start the process. Once we hit the select button, the 3-jaw goes home, and then it grabs the rotator body and starts rotating. At the same time, the linear motion is occurring, so we're pulling and tightening the spring at the same time. The load cell here is measuring the friction between the spring and the push rod. Here we can see the stepper motor that's controlling the rotation and the rotary encoder that allows us to see where the rotation is at any time. The rotation continues until the load cell registers friction. The whole process continues until a set point of 30 pounds. Once the preset load is reached, then the system stops. In this proof of concept module, everything's moving at a relatively slow pace to show how things are done. So the rotation is occurring See, the load is continuing to increase as the spring grabs onto the pull tube, push rod. This continues until a preset value of 30 pounds. And the system stops. The system memorizes the position at which the rotator body has stopped. Then it returns home while continuing to grab onto the rotator body. At this point, the PLC is instructing us to remove the push tube. With the push tube removed, PLC is instructing us to hit the start button again. So we'll hit the start button. The system rotates to the point at which the load was 30 pounds, and then it rotates an additional offset angle and drills a hole. That offset angle is included to take up the slack in the system, actually in the product itself. Once this is done, the part can be removed and assembled into the device. So now you have a matched set of tube, spring, the clasp rotator, and the rotator body. And this will move along as a kit through the rest of the assembly process. This will be the kit, which next thing would be to put the dowel pins in to secure the rotator body to the clasp rotator. And then this assembly would move forward for the remainder of the product assembly and testing.